Before we get into graphing exponential functions, I want to look back for a second. Remember Math 10C? In Math 10C, you did something called a linear function. Okay, that was in the form of y equals mx plus b. That's beautiful. And the graph, there's your x and y axis, would basically look like a line. Then in Math 20-1, you did something called quadratics. Okay, you did a quadratic, which was in the form of y equals ax minus p squared plus q. And here's our nice little quadratic where that little point was a p and a q. Okay, the last one I want to look at here, and this is what you're going to do in Math 30-1. In Math 30-1, you're going to do something called exponential. Now, I'm not going to give you the graph of this guy yet, or the equation of this guy yet, but I do want to show you what the kind of typical graph will look like. It'll look like that, or it'll look like this, which is really cool. But here's what I want to show you. The second letter tells you the type of graph it is. Look at this. Linear looks like a line. Yep, there's your line. Quadratic looks like a, yep, there's your U, right? Okay, exponential, there's your X, either this way or this way. So that's something to kind of keep in mind when you're trying to remember the type of graph that you have. First graph that I want to look at is this one here. This is going to be a function of y equals to 2 to the power of x. And I want you to see what this looks like. Y equals 2 to the power of x. I'm going to boot up my calculator here, and I'm just going to put in 2 to the power of x. And I really want you to see what this looks like. It looks very, very cool. I'm going to graph it. There's that exponential function that I want you to notice. And a couple things about this exponential function is this. Notice how this graph goes like this and then comes right up through there. Perfect. So in other words, you could tell me that that's a horizontal asymptote. But this also goes on forever and ever in this direction. So it has no real limits on its domain. So it can continue on from way out here going like this, like this, like this. It'll pop right through there, and it'll just continue going upwards like this. So it does in fact have a horizontal asymptote, but it does not have a vertical asymptote. It just keeps on getting bigger and bigger. Let's see why. Let's go over here. I'm going to clear the ink out of this guy. I want you to be able to see something though. I'm going to go second, and I'm going to hit the table. And I want you to see what the table looks like. Look at this. Minus 3 is 0.125. Okay, so there's 0.125. Bring that thing back up. Minus 2 is 0.25, okay? Minus 1 is 0.5, but here's the interesting one. 0 is 1, then we go to 2, and then we go to 4, and then we got to click it one more down here. Let's see. And that one goes to, oops, let's keep on going. Come on, thing. There we go. That goes to 8. So basically, all I'm doing in this particular thing is putting these values here into the exponent now. So you have to remember where this comes from. Take a look at this. How did we get this value? 2 to the power of negative 1. And if you remember your exponent laws from grade 9, that actually means 1 over 2, which of course is, there it is, 1/2. This here, this question here now is 2 to the power of negative 2, which of course means 1 over 2 squared, which is 1/4. There's your 0.25. 2 to the negative 3, of course, is 1 over 2 to the 3, and that's going to be, of course, 1/8, and 1/8 is 0.125. But I want to show you something also that is very, very interesting. What about this value right here? You're going to see an interesting trend with this particular number. Why? Because look, 2 to the power of 0, remember the law. Any base to the exponent of 0 is always going to give you 1. So if we go on to another question here, like this one here, where I'm going to give you another value of y equals to 1/2 to the power of x. Let's see how this changes things. Let's go back to our calculator here, go back to the y equals 2, and we're going to compare. So I'm going to shut this graph, this portion of the graph off just by hitting equals there. Move it down to here. Our y2 is now going to be a bracket, 1 divided by 2, bracket to the power of x. And watch what happens to the graph. Here we go. Graph. Look at that. Isn't that interesting? So instead of going up like we did with the other graph, instead of going up this way, We are now going the opposite direction. But I want to show you something which is really, really cool again. Wait, let me just draw this out. Boom. Here. I want to show you something that's really, really cool because, again, think about this. This is 1/2 to the power of, let's do the first one, -3, which means to flip it. Look at that. Isn't that interesting? That's going to give you 8, whereas before it gave you a fraction. This now is 1/2 to the -2, which is going to be 2 squared, which is 4, right? That was 8, that's 4. This is 1/2 to the -1, which is going to give you 2 to the power 1, or just plain old 2. Now here's the thing that I want you to look at here. Look at this. Again, it doesn't matter what the base is. When the exponent is 0, you will always get 1. So notice that this graph, again, goes through the 1. But in fact, we do have another horizontal asymptote. Interesting, interesting, interesting. So let's go through a bunch of stuff here. Let's take a look at a variety of questions and see what it's going to look like. First things first. Here is y to the 4x. And if you want to see what that looks like, just go out and plot it. I'm going to clear the ink on this guy, go right to your y equals 2 and plot it. Let's clear these guys out of here. Okay, 4 to the power of x. What do you think it's going to look like? Well, let's graph it. Let's see. Well, look at that. It looks exactly the same as before, maybe a little steeper, but look at that right there. At, guess what? 4 to the power of 0, when x is 0, we're still 1. That's the most amazing thing. And again, this is a horizontal asymptote. So I got a question for you. Are we going to have an x-intercept then? Well, no, you're not. Are you going to have a y-intercept in this case? Well, yes, you are. Why? Take a look back at the graph. What's your y-intercept? It's 1, right there. It's 1. So is there an equation of an asymptote? Yes, there's a horizontal asymptote. And that is, of course, going to be at y equals to 0. Okay, what's the domain? Well, x can be anything you want it to be, but the range has to be above 0, and it can't be equal to, so I made a mistake there. It can't be equal to, it has to be greater than 0 because, of course, of your horizontal asymptote. And your quick sketch on this, of course, is going to look just like that. So let's do the rest of these real quick now that we know that what we're doing. Here's a number bigger than 1. So of course, this quick sketch is going to make it look just like that. Don't believe me? Well, let's go back. It's 5/3 to the power of x. Let's clear this ink right here. Go y equals 2. Clear that. Bracket 5 divided by 3. Bracket to the power of x. And let's see what it looks like. Sure enough, it's exactly the same. And again, it goes through the 0, 0. I should say the 0, 1. So here we go. Does it have an x-intercept? No. Okay. Does it have a y-intercept? 1. Horizontal asymptote is the same. Domain is the same. Range is the same. Looks the same. Now, let's go to the next one. Look how this is now a fraction. No intercept. Still a y-intercept of 1, still the same asymptote, still the same value of r, still greater than 0, but what happens to the sketch here? Remember now, it starts this way and goes that way when they're fractions. Same thing goes with this. This is the same, the same, the same, the same, the same. And again, if you have a fraction, it's going that way. So let's just do a quick summary of everything that we look like. All of these graphs look like a curve going this way or like this way. So they look like an X. Graphs generally have a domain of X is an element of R, okay, and a range of Y greater than 0, okay? If the base is a number larger or smaller than 1, what happens? Okay, larger than 1, it tells you that it's going this way. It's smaller than 1, it's interesting what's going to happen when it's a -1. It's actually going to look a little bit like that. But if your graph is between plus or minus 1, check this out. You're going to have a graph going this way or a graph going this way. Let's prove that because we didn't really prove that on our summary. Why is this and this like this? The reason why is because consider the graph. Y equals to some number to the power of x. One of them is going to be negative. What happens when this thing is negative? Let's take a look-see. It becomes really, really bizarre at that point. Okay, so watch this. So let's put in, you know what? We could just go second insert. Let's put a negative right into this one and see what it looks like. Graph it and watch what happens. And sure enough, it's going to go down. Why? Because what you learned in the last unit is that negative up front means that you're a reflection across the x-axis. Oh, good golly, Mr. Pryma. Does that mean that I'm going to be able to use the same stuff that I used last time in terms of horizontal and vertical transformations on graphs, and I can use those exact same ones for exponentials? You betcha, and that's the basis of this entire unit.